this is actually a really interesting case where astronomers think that here a star went directly to a black hole, meaning to say the phase of supernova explosion where you have this bounce back and things like that, it did not happen.
Because it got a little bright, but not supernova bright?
That's exactly right, and it just, boom, it just went into a black hole. And so this is a rare case. There is only one other instance where astronomers had suspected something like this, but astronomers think that this may be one of the first case where a star may have directly, or not star may have, we have detected a star which may have directly gone and formed into a black hole without supernova.
Time is all relative. That's what we learned from you, Hampshire College astronomer Dr. Salman, Mr. Universe. And so, like, now I saw a funny meme yesterday saying I am not figuring out how to change the clock on my microwave, which doesn't automatically update. This is now kitchen standard time. It's on its own time zone. Everything else changes on its own. So, but the light has changed. It feels like spring, and we are here at your Amherst kitchen table for some more kitchen table astronomy, Mr. Universe. I am told that we're talking about a star collapsing in on itself as a black hole, not Timothee Chalamet, after his statements about ballet and opera, getting him in a lot of hot water right before he's gunning for that Best Actor Oscar. I think his chances just plummeted into black hole levels. But
not as much as Jessie Buckley, who...
Oh my God, please don't tell me she said something bad.
Well, I'm fine with that, but she said she doesn't like cats. And not the Broadway.
That one would be okay with me.
Yeah. No, so people were really upset, and then the backlash was actually quite a bit, and to the extent that she had to take back and apologize, and she actually likes cats.
I'm glad I missed all of that, because I also saw her new movie, The Bride.
Oh yeah,
Jessie Buckley is going to win. There's no question. She's winning Best Actress.
Okay, I have not seen that. So.
The Bride is a lot of fun.
Okay, yes.
I wish it was a little weirder, but it's great.
Wow,
it's great. I wanted them to either lean really hard weird or a little more serious. It's kind of in the middle in a way that I thought could have, but I thought it was great. Anyway, let's talk.
Yeah, but before I do, I thought, so we are going to talk about astronomy, and we are in the Valley, and as you know, in most places here, we also start with the land acknowledgement.
Yes.
Acknowledging about the injustice and the land that was unjustly taken from native tribes. And that is in the past, and meaning to say that that injustice happened in the past. And so we start with that oftentimes talks here in the colleges and at other places. And I thought, while talking about astronomy, it may also be important to, do an acknowledgement right now of the injustice that the U.S. is involved in, illegal war, which is taking place right now. So I think this is a good time to actually start everything by acknowledging the injustice that we are doing right now.
Right.
Later on in the future, past acknowledgement, fine, but I think a present acknowledgement of what we are doing wrong in Iran that is taking place, bombing of cities that is taking place, bombing of boats that is taking place, and also the weapons of the U.S. that are being used, for example, right now, bombing in Beirut, bombings in Gaza, and the injustice taking place in the West Bank. And before somebody says, but you should acknowledge all wars that are taking place. There are a lot of injustices. The world has no shortage of injustices. But there's South Sudan, there are other places that is taking place, and Pakistan is involved in Afghanistan, but I think this is a much more direct involvement of the U.S. Monte, you and I, that's our country. If our country is involved, I think it's important to acknowledge it. So I just think this is the time to speak out. A lot of people are speaking out, but I don't want, while we talk about astronomy, while we talk about the Academy Awards, which are coming up on Sunday, we talk about all of these things, and there is a whiplash in some sense of the type of thing we are talking about versus the type of things that people are experiencing, both from I mean, in some sense, we talk about American science, American culture, but also American bombs. So I think all of those things need to be acknowledged. So we'll talk about astronomy, but here is an acknowledgement that right now we are in the U.S. is involved in an illegal war, bombing people in Iran, and it's a shame.
$1 billion a day, the estimate, and we always say there's not enough money for food, there's not enough money for science, there's not enough money for this or that. When it comes to a war of convenience or inconvenience, or a war that you've done for no articulable reason, still plenty of money for that. That acknowledgement aside, a star has collapsed in on itself into a black hole.
Right, so this is an interesting story. So we know black holes exist, and both in terms of the star-sized black holes and also at the centers of galaxies. So those are the supermassive black holes. And recently we have talked a lot about supermassive black holes, how they form. Like James Webb Space Telescope is, as we speak, is untangling that mystery, and we are getting closer to having that answer. But we also know how stars that are large stars, how they form into black holes. So we know that our sun is never going to form into a black hole because it doesn't have enough mass. Its end stage, when it runs out of fuel, basically the nuclear fusions that are taking place, its end stage is going to be what is astronomers call a white dwarf, an object the size of the Earth with the density of an atom. But you cannot compress it further. It doesn't have enough mass to basically shrink it further. Another way of thinking about that is that basically the star's life is a battle between gravity, which is trying to shrink it, and whatever pressure that it can come in. Mostly it comes from radiation, light. So if you have nuclear fusions going on, it tries to balance it out. That's when you look at the sun right now, it is in balance because of the energy that is being produced in the central region in the core. It is balancing the pulling down from gravity. Mm-hmm. But when you run out of fuel, it starts to collapse further and
gravity
further.
wins.
Gravity wins.
It's like middle age.
And until you get to the density of a white dwarf, which is basically the density of an atom, it cannot pull in further because atom says, well, that's it. Mm-hmm. And but if you have a star bigger than the sun in terms of mass, then you can actually become what astronomers call a neutron star, where the size shrinks all the way down to size of like the New York City, right? So and there the density becomes the density of a nucleus of an atom, so much bigger. But for that, you need to have a star that is the size of probably about 10, 12 times the mass of the sun. And so, again, we have seen neutron stars, we've detected neutron stars, we have tested it. But when this happens, there is a big explosion that takes place, which astronomers call a supernova. And the way it happens is that, so again, there is this battle going on between the light radiation or heat that is keeping the gravity or preventing the collapse of the star. And that's a much bigger star. But then in the core, you stop nuclear fusions, and there are reasons for that. So, so you in the core, at one point, you stop any kind of energy, and so suddenly the star starts to collapse back. Mm-hmm. But when you get to the core, and you get to the density of the nucleus of an atom, basically all neutrons in there, then it cannot push further, and so
it literally squishes down to the size of one atom.
Well, not one atom. But you have all of these neutrons stuck together in the size of New York City, of a city.
Okay.
Right. So, but it cannot squish further because the density is so much. All the neutrons. So electrons.
But our star will squish down to the density of one atom.
No. Well, again, same thing. So again, that's the size of the Earth. Uh-huh. But those will all be atoms touching each other, and you cannot push it further.
Okay.
But with a bigger star, you can still take the electrons and push them into the nucleus, and hence turning them into neutrons. And so you already have neutrons over there, and so you will have the density of a nucleus of an atom, all neutrons pretty much. And
wait, one more quick thing.
Yeah.
So the bigger the star, the smaller the crush is.
Yeah.
So because our star is kind of medium sized, it'll get crushed into an Earth-sized thing, even though our sun is 1,000,000 times the size of the Earth.
That's correct.
A bigger star would get crushed even further down into the size of Manhattan.
That's right. And once it's coming down, and so then suddenly it stops because the density is there, and the material is falling down, and suddenly it stops. And that creates a shock wave. And it starts to move back up. Okay, now.
And that's the supernova?
Hold on, not yet.
Okay.
But the material from the top is still coming down. It doesn't know that the material close to the core of the star has rebounded. And as you can imagine, the two things crash into each other, and that's what causes. So that shock wave that has rebounded meets the material that is still coming down happily, and that's what creates the supernova, which is one of the biggest explosions in the universe, because it blows up all the sort of the envelope of the star, and for a brief few weeks, or few days to few weeks, the star becomes brighter than all the stars, or basically they're brighter than the galaxy itself.
So that's a supernova. But Nova is a super show on WGBH, which is our parent company. We're in the middle of the fund drive, 800-639-8850 or nepm.org, a subsidiary of the organization that brings you Nova.
Nova is lovely.
We love Nova.
But supernova on the other by the way, that's
it's like Grover and Super Grover, also available on WGBH and WGBY television.
That name is still available if you want to have a sequel to Nova.
Supernova.
Yeah. So that's what happens, and you are left with this core. And oftentimes, if you cannot hold this neutron star, so you have left with this city-like core, but sometimes the material still falls on it, and it cannot even sustain the density of the nucleus of an atom.
Okay.
So what are you left with? Nothing. Or you are left with a black hole. That's where an object whose density is so much that that even light cannot escape from it. At the center, you have a place where our laws break down right now, but we know they exist because we can detect them indirectly through material falling onto it or objects circling around it, and we can actually tell, that object was a black hole. And usually for that, you need a little bit or bigger star than even 8 or 10 times the mass of our sun.
So it's cool because medium star like our sun,
or small, or all small stars. I mean, they all turn into a white dwarf.
Crushed down into an Earth-sized object. Bigger star crushed down even smaller into a Manhattan-sized object. Super big star crushed down so much into mystery object that we don't know what it really is, but we know exists, called black hole. We don't know what happens in that black hole still. Scientists don't know what goes on in there. They can see the evidence around it, right? But they don't know what it is or what happens in there.
Well, so right in the middle is what astronomers call a singularity. That is a place, again, if it's a very small place, and so usually for that level, that scales, because we are already, in terms of individual things, we are already talking about the density of nucleus, and here it's smaller than that. So usually we describe things with quantum physics.
Okay.
The problem is that when we talk about gravity, that is explained by Einstein's general theory of relativity, because that explains the large-scale structure of the universe and gravity. As of yet, we do not have a law, if it exists, a theory, if it exists, that can explain or that can combine the two together, meaning to say that can provide an explanation of how gravity works at very, very small quantum scales, and vice versa. And so this is one of the big searches for it as well. It's sometimes called the theory of everything. String theory is one of the ways, but we do not yet know what theory explains it. And because we cannot explain it, that's the reason why we exactly don't know at those scales what happens and our laws break down. But this is not what we are talking about. What we are talking about is, so sometimes, and most times, we expected that this supernova also happens before the formation of a black hole. So neutron star formed, but then more material fell in, and it could not sustain itself, and it goes into this black hole. We know black holes exist. We have good evidence for that. And so this happens. And this also, from the explanation, from our understanding of stars, which we know very well, we can actually chalk out or all of these steps going to the formation of the black hole. No issue.
Okay.
Now, here is the cool part. So astronomers can detect supernovae because those are really bright things. In fact, those are really important for measuring distances and other types of things. But here is a case that was detected about a few years ago. Astronomers looked at data from a telescope that was looking at our neighboring galaxy, Andromeda. And they were looking at, well, how does the light vary, or objects that vary in brightness and things like that. And what they found was that there is one star, and this is incredible. So you're talking about, Andromeda galaxy has a few 100 billion stars. It's a little bit bigger than the Milky Way. And what they found was that one star in 2014 brightened a little bit, and with a big star, it brightened. And then it dimmed a couple of years later, and it kind of went away. And they were like, well, they were looking for it. They found, they looked for it with Hubble Space Telescope, and they could not find a star where there used to be. So there was a star. They could see it. They can go back and in our archives and look at it. There was what astronomers call a blue supergiant. There was a big star over there. Then it brightened up a little, and then it started to fade, and then it just gone. Now, James Webb Space Telescope found a little bit of gas and dust expanding over there.
Hubble and James Webb use different types of light to assess, so they can see different things.
Thank you, Monty. Hubble Space Telescope looks in the visible light, and James Webb Space Telescope in the infrared. And infrared is the one that can actually look at gas and dust much more clearly. And so they found, there is this gas left, which is expanding at some leisurely pace. It's moving up, but there is no star. I was like, wait a minute, what happened to the star? And so this is actually a really interesting case where astronomers think that here a star went directly to a black hole, meaning to say the phase of supernova explosion where you have this bounce back and things like that, it did not happen.
Because it got a little bright, but not supernova bright?
That's exactly right. And it just, boom, it just went into a black hole. And so this is a rare case. There is only one other instance where astronomers had suspected something like this. But astronomers think that this may be one of the first case where a star may have directly, or not star may have, we have detected a star which may have directly gone and formed into a black hole without supernova. Okay, so what are the implications for that? Well, what's interesting is that, if that happens a lot, for example, which we don't know how frequent it is.
Yeah, because we've only seen this one example out of the hundreds of billions of stars in the universe.
And it is really hard to find. When you are looking up, even when you are seeing galaxies, you are seeing light from hundreds of billions of stars at the same time. And so if one of the light just goes into a black hole, to detect it, you really need to be focusing on high resolution where you are looking at individual stars and you are looking and mapping it basically from day to day or from a few days or so, because one thing would be gone. And so it's a really hard problem, but the significance of that is that now we know that this does happen. And fortunately, and this is, to me, this also looks like, if I didn't know better, I would have said, this must be a PR stunt from the Vera Rubin Observatory, which has just got online and which is planning on basically mapping the entire sky. Now, it's going to be in the southern hemisphere, so mostly from the south, entire sky every 3 days, meaning to say it's going to cover, it has a huge camera, it's going to cover, and it's going to be looking at the entire sky and almost creating a movie out of it, because over the period of time, it's going to have what is changing. And something like this would be a great candidate because it can actually identify, it's the whole thing about how much data it's going to produce. There is a whole thing about how, we're going to handle it. But you can imagine many candidates where, computers are going to identify, AI is going to identify that, hey, wait a minute, here are these objects that actually disappeared. They used to be big stars, and today they're not there. What happened? And they can actually go back and look at it and trace the final days. And we normally talk about millions or billions of years. Here we are talking about things happening within a few days or few months or a few years. And Vera Rubin Observatory is going to do that. And from that perspective, I should mention on February 24th, it started functioning, the Vera Rubin Observatory. It had taken some test data before, but on February 24th, and just the first night, it gave out 800,000 alerts to astronomers, meaning to say they were like, oh, I found this, oh, I found this, oh, I found this. So this is one of
shut off push notifications real quick for the Vera Rubin telescope.
And so the idea was, I mean, it's not finding all these stars turning into black holes, but rather asteroids moving. It is finding sort of like, stars brightening, or novae, supernovae, all of those things. And anything it finds different than before, it goes like, hey, look at that. Did you see that? And the numbers are expected to go from 800,000 to 7 million per night once it's fully operational.
Wow.
And so, yes, I think it's always important to switch off notifications when you go to bed.
And it's great to know that if a star mysteriously vanishes over a relatively short period of time, that we are tracking it from here. We can see what it went through to go from star to mini supernova. I guess we'll just call it nova.
Not even a mini supernova. That was just a little bit of brightening. That could have been just sort of like, a little bit of material that went off. So it's not even close to nova supernova, because otherwise astronomers would have been much more alert to that. No, it was just a little brightening, and then it just...
And now it's a black hole.
Now it's a black hole.
Yeah.
That's what we think, because there is nothing there, and there used to be a big star there, so that is our assumption. But to me, that also, again, connecting back to the larger perspective, I mean, I think... Yes, we are thinking about it, and we're like, there are hundreds of billions of stars in Andromeda Galaxy, and one star just went sort of like, went into a black hole. But you can also think about, and that's what shows like Star Trek does, for example. Like, okay, what if we were close to it, or what if we were nearby, and things like that. I think that's also interesting about perspective. So here was a big star. It probably lived millions of years, tens of millions of years. Stars that are big, by the way, live much shorter life. Stars that are smaller live much longer. And so our sun lives its lifetime is in tens of billions of years, whereas these stars live tens of millions of years. But nevertheless, what if sort of like, there were planets around it? Probably there was no life because there wasn't enough time to develop. But what if you were in a neighboring star system and you could see it, like Betelgeuse, or some other star system, and you go like, it was in your sky, and then suddenly it's not there, and you were like, what happened? So so you can actually imagine these things happening in the universe. For us, it's just a little, not even a dot. We have to use telescopes to look at that. But for some, it may be even more important, and it may have just disappeared out of the sky. So that is kind of cool.
I want to go back to Timothee Chalamet and be like, you were a big bright star, front runner maybe for the Best Actor Oscar. Say something bad about ballet and opera. Black hole.
Although he should have won for playing Dylan rather than...
I don't think so. We'll see what happens next Monday. We'll give a whole Oscar breakdown by then we'll know who won everything.
Can I mention one thing? I haven't seen it yet, but there are Oscar shorts, and one of the documentaries, I just seen a little bit of a trailer for that. It has somehow it has donkeys going to an observatory, and so I haven't seen it yet, but I am
documentary short.
A documentary short.
I have a lot of things to watch before next Sunday. I will also say
they are playing. By the way, these shorts are playing at Emmer Cinema.
And the also the feature short, well the dramatic shorts or whatever you want to call them, including one called Singers, which includes Amherst resident Chris Smither, a musician. I watched that one. You can watch that one on Netflix. It's excellent. So we'll see. We'll see what stars are missing next week from the Oscars and what stars are missing next week from the sky.
Yes, and go see it at Emmer Cinema as well.
Shameless plug, board member of Amber Cinema.